All right, we'll call this nap time. So y'all take a nap. I'll just lay up here. Let's see, we got 3 minutes. All right, folks, how many, so I'm American, so if I say American things, I'm sorry. Who's first NDC? Okay, that's a good number of hands. This is my third NDC. For some reason, they keep inviting me. I don't know why. And this is the first time on the big stage. So I'm a little anxious about this. So you all would do me a favor by kind of pumping me up, like, go Kevin. I mean, or don't. It's all right. Yep, so y'all just had the rice, I bet, and you're all getting that carb low right now. You want to take that nap. All right, I know how it is. Everyone got all silent. Sorry. Any fellow Americans in here? No? Awesome. Excellent. No countrymen. All right, so anyone not from the UK? All right. Better. Anyone not from Europe? Okay. I like to, I saw a hand. Where are you from? I'm sorry. South Africa. Excellent. That was quite, how long's your flight? Couple hours? 12 hours? Okay. A couple hours. You know, I'm American. We don't know geography at all on this side of the world. So, all right, that is quite the all. Anyone farther than South Africa? That's not a speaker, is probably a good way to put it. Yes, sir. Where are you from? New Zealand. I'm sorry. That is quite the haul. I was chatting with another gentleman who was from, I don't know, same continent, but he was talking about how bad his flight was, and I'm over here complaining about my 6-hour flight overnight. And when you go home? When do you go home? Oh, you live here. Oh, so you missed the whole point of my discussion. All right. So if you're going home on Saturday, I was trying to make, but excellent. All right. I think I'm at time. All right, 1:40. So welcome, everyone. Make sure you're in the right room. I had to double check at least 5 times to make sure I was in the right room. So tactics for building background services in .NET. I'm Kevin Griffin. And I have done this talk a couple times in front of user groups, just kind of warming up, figuring out how I wanted it to flow in different ways. I always had trouble with the start, because the beginning of a talk is kind of important. I have to get your energy up. I'm after lunch. And this is kind of a boring topic. And like, all things said, this is a boring topic in terms of software development. But I have talked to enough people, and I have done this talk enough times, where the boring topics are most useful to people. So I'm hoping at the end of this talk, each and every one of you, as you're putting green in the box on the way out, you say, I have gotten something out of this that's useful. So how do you start a talk like this? I actually got this idea from my pastor, which is a weird thing. I was in church, and I have a slide for this. There we go. Not my pastor, just stock photo. He didn't like me taking his photo. And I had this idea because he was up there, and I go to one of these more, not a traditional churches, one of these, like, we call them strip mall churches. I don't know if that's a thing over here, but it's a church startup, and it's mostly entertainment, and then coming out, and they talk about, all the church stuff. And I see the pastor up there, and he's doing his thing. I'm like, I don't know what the pastor does outside of the performance. And I say this as a person that's behind the scenes. I'm running a camera for the church. I'm helping with sound at the church. But there are people running around doing all the work to make this worship happen. And the pastor just has to show up and present. Now, all things said, and if he ever watches this, I'm sorry, he does a lot more than that, but it seems like from an audience perspective, he just gets up and does the work. All the background work is being done by the people behind the scenes. And if you've ever been to a concert, if you've ever seen a political person speaking, or just a like a life coach, like a Tony Robbins. I don't know if there's a appropriate analogy over here. Someone getting up and they're doing the presentation, but all the work is being done behind the scenes. Take any concert you've ever been to, any major concert you've ever been to. The folks up playing the instruments, singing the songs, they're not the ones running the cables. They're not the ones tuning the guitars. They're not the ones switching things out. Those are all being done asynchronously behind the scenes by background services. So I had this thought, this epiphany during a worship service. I went, wow, this church environment is kind of like how we should be building applications. And your application is no different than any of the examples I just mentioned. Your UI is the presenter. It's out there talking to the world, giving them information, and taking back feedback from them, but it should not do anything important. And this is kind of my opinion. Your front end, your UI, should be relatively dumb. What it should be good at is marshaling or delegating those tasks to other services in the background and let them go do the work. So this is obviously a UI that I did not design because it looks really good. And I want to use it as an example of a real story of an application I walked into a long, long, long time ago, where we had something very similar to this, not as pretty, but I want to focus on this Pay Now button at the bottom. And our app was not what you would call good. We had technical debt, and we loved it. Like every little bit of technical debt we could add, we put in there. So I came onto this application, and the workflow works something like this. I'm leaving some of the tidbits out, but you pay now. We go into the back end, we create an order, we check the inventory, we charge the credit card because you got to take the money, and then finally we send the email saying, hey, you're all good to go, and then we send back the success, the confirmation. There's a fundamental flaw with this plan. Email server isn't reliable all the time. Anyone who sends transactional email into your system knows email services are not reliable. They go down. Ours would go down every now and then, right after it charged the credit card, like a hard charge. And it would send back an error to the front end saying, hey, there was a problem processing your order, but we had processed their order. We just didn't send them the email. And it was one of those problems where we're like, we should fix this. But we didn't actually ever fix the problem. I ended up leaving the project way before those problems ever got fixed. And you're out there probably laughing, going, that's not how people write applications anymore. But, we're all friends here, right? Right? You know these applications out there run every single day. These are the applications that ask you not to press the back button because they're doing this stuff in the background. They don't want to double charge you because they totally would double charge you. All right, so all things says, hi, I'm Kevin. Hey, yep, there we go. Audience participation is amazing. A little bit about me. I'm a Microsoft MVP. I love working in ASP.NET Core, building applications in Azure, and anything web development. Independent consultant working with a couple fairly large companies in the US. And I would love to talk to you anytime after this session. If you have questions, here's my contact information, including Mastodon. Are we still doing that? Maybe? I don't know. Okay, never mind. You can talk to me afterwards. I would love to chat more. I have a course on SignalR that I'm trying to get you all to buy, but because I love NDC, I'm giving it to y'all for free. So for the next 5 days, you can use the code NDC London 2023. I'll drop this in the Slack in case you don't want to snapshot it. And I would love for you to go get a copy and give me some of your feedback. Don't sign up unless you're giving me 5 stars. That's the rule. And you're not allowed to leave unless you give me a green slip. All right. Our agenda for today, I have a limited time. My goal is to put some tools in your toolbox. We all have these mental toolboxes of ways we know how to solve problems. And we've all been in that case where we're in a meeting I know exactly how to solve that problem because I only know one way to solve that problem. But with something like background services, there are multiple ways to solve the problem. And it's all case specific. We've all used the term, how do you do X, Y, and Z? Well, it depends. We've all said it. Here, I'm going to give you the various cases of it depends. And some of them won't apply to you at all. Some of them you probably already know about. Others, I'm hopefully teaching you something new. Let's go back to our problem of the Pay Now button that just is awful. How should we do this a little bit better? First, the Pay Now button, still you click it. We still want to create our order. In the US, we have a problem with Amazon. I'm not sure if that's a problem over here as well. We just like buying stuff on Amazon. And if you've ever ordered anything from Amazon, you click the Buy Now button, and it doesn't give you back a confirmation that your order has been charged and shipped. It gives you just back a confirmation that your order has been received. And that's all we really wanted to do in our situation. We want to create the order and confirm with the user that it's been received. They can go about their day. But in the background, we want to start a workflow. We want to start a process that will eventually take the system to a point where we are charging the credit card and we are shipping the product. So the 3 steps still apply. They're just being done asynchronously of the Pay Now button. Check inventory, straightforward. Do we actually have in stock what we said we did? Yes, no. Charge the credit card or other form of payment. There's been a number of times I have gone onto an Amazon, hit Pay Now, thought I was using a good credit card, and then a couple minutes later, I get an email from Amazon saying your payment method was bad, and you need to fix it before we will continue with your order. If you don't do anything, they cancel it. So this is a step up in the asynchronous process. Let's charge the credit card. If we can't, we try to fix the problem, and then we jump back into the workflow. And then finally, when everything's said and done, we ship the product, we send the email, and you start watching the tracking codes every 5 minutes. So we're talking about background tasks, background services. There are 2 types I'm going to kind of lump into this talk. There's on demand, where we have processes that need to happen now. I hit the Pay Now button. I need to go check inventory. I need to start that workflow. If you're pressing a button to send an email, well, we don't want to wait till later to send the email. Let's get a workflow going to send the email. I do all kinds of on-demand services. So email is a great one. Checking payment processing. Webhooks, so the most popular one we use is Stripe, and we get webhooks for subscription updates. So if a payment fails in the future, we get a webhook saying the payment failed. We send a notification to our customer via that webhook. That's something that we want to do on demand, basically. And then in any processing, what I kind of mean by this is we have data that's coming in all the time. As data is put into our database, we set up asynchronous processes that go and clean that data up. A lot of cases, we have to go look up geographical information. And this is not stuff that needs to happen immediately, but it needs to happen eventually. We also have scheduled or reoccurring tasks, and these are things that happen on some sort of schedule, like a cron. Our most common one is probably hourly, but we have some that we do weekly or monthly, and they're just boring things that have to happen on a schedule. Generally, these are reports or any sort of resource cleanup. One of the first ones I ever wrote was we had a directory where it was just filling up with log files. And we never cleaned it up until we ran out of hard drive space. So we wrote a job that would go clean it up every 30 days. Simple things that aren't really glamorous, they're really boring, but they're critical to production applications. When you're building a background service, there's a couple of considerations you should make, because this is the it depends. First, where are you going to host it? If you're local, anyone out there building, let's say like thick applications, WinForms, WPF, was it Maui now? Okay, I was waiting for the hands. I'm like, do y'all just not want to admit it? I'm sorry. So I'm assuming the rest of y'all are web developers. No? Come on, folks. Raise your hands. You're a web developer. Be proud of it. All right, cool. So if you're the few people that are building real applications on the desktop, you really don't have that many cases. You can do a Windows service, which are actually really cool. They're coming back into style. You could do this work inside your existing client app, which isn't really good unless the client app's running. If you shut it down, it's not going to do much. The rest of us who are web developers, if I'm running an ASP.NET Core app, I can actually run it inside the process. So my web app is also performing my background services. If you're deploying the cloud, now I'm very partial to Azure and Azure Functions and Azure Logic apps. I love that stuff. But if you're over on AWS, you have similar services that are available to you as well. We need to consider resiliency in our background services because I have a couple projects that we have inherited where they were basically console applications that ran forever. And if they threw an exception and it wasn't handled, it would crash the app. So you get that call saying, oh, the checker's down. Okay, well, someone has to log into the server. You have to restart the service, and then everything comes back up until it crashes again. And it crashes infrequently enough where no one wanted to solve the problem. So no one really did. But when it comes to background services, we need to be aware of resiliency. How do we handle a case where a task fails? If I'm trying to send email and my email service is down, what do I do next? Well, in most cases, you wait 30 seconds and you can try again. If I try to charge a credit card and I don't get a success back from the credit card company or the payment processor, do I try again after a period of time? That's up to you. What happens if the server crashes? So my console app crashes and someone has to log into the server in order to fix it. That's not the best way to go. We need to consider what are the ways to fix that problem. All right, I'd like to show you a couple tactics. We're going to run through them. I'm actually not going to do any live code. I'm just going to show you example. We're going to move fairly quick. First, I want to talk about .NET hosted services. I'm making a good assumption. Most of you are probably on anything beyond .NET 3.1. Now, if you're out there going, we're still on .NET 3.5 from the previous generation, I'm sorry, this talk is not for you. But I want to talk about .NET hosted services. This was added into .NET Core, and it's a really cool concept where your .NET host, your application, can manage background services for you on your behalf. And you can have one, you can have 15. You just create them using their implementation, and the .NET host will automatically manage them for you. And I say .NET host, when we originally got this feature, we all kind of thought it was just for ASP.NET Core, but it's not. We can use this in .NET console applications, we can use this in Windows services, we can use it wherever we want. And it's a pretty straightforward implementation. You create a class, and you can implement from background service, or you can also implement from iHosted service, but it's a little bit more effort. Background service does more for you underneath the scenes. And you just write code inside of your execute async method that you're given to do the work. And when that method returns, whether on purpose or not, the background service is done. It has done all of its work. So this just runs continuously in the background for the lifetime of your application. And what's really cool is because it's inside the facade of a .NET Core, .NET application, you get all the benefits of .NET. So if you want to use dependency injection for your logger, for any of your own dependencies, you just inject them, and .NET will take care of the rest for you. To run it, it's as easy as going into your application host. So this is for a console application, but it's very similar if you were doing an ASP.NET Core application. And in your services, you say, add hosted service, tell it what service you're adding, and it takes care of the rest for you. So I thought it would be fun that we build a Windows service. So I'm going to jump into some sample code real fast. Actually, let me show you this first. So everything I'm showing you is based off of this package. Who's ever built a Windows service before? Not with Top Shelf. Oh, you see the hands go down? Oh, yeah. So Top Shelf was really great back in the older .NET days because it helped you. If you were building a Windows service from scratch, it was a pain in the butt because there's all this unwritten, undocumented, or hidden documentation for writing a Windows service. You have to handle the /s command or the /whatever command, and they all do different things within Windows, but you don't know that the first time you're writing a Windows service. And back then, we didn't have Stack Overflow. We didn't have ChatGPT to tell us how to do all this work. It just was this hidden knowledge that was passed down amongst the elder developers. Now, you just go install a package. I'm not going to say it out loud. So Windows services, and you add literally one line of code. Use Windows service, and you can set some configuration. It will take care of all the crud for you automatically. I love this, and I wish I had this. Now, Top Shelf did a lot of this for you. It was just slightly harder, but it was easier than the alternative. Now we can jump into my demo. So I have a demo, just kind of outlining, and all this code is going to be available for you afterwards, where we take the example I have on screen. This is a console application, basically, where we're creating our host, we're adding a Windows service, and then we're adding a hosted service. So the Windows service part is not actually going to matter yet, but the hosted service part is. If we go into my cleanup folder service, and this is a very straightforward example of cleaning up resources. Every, 15 seconds, I want to go check a folder, a temp folder, not an important folder. I made that mistake once. We're going to go through, and we're just going to see if there are any files in there. If there are any files, and any files older than 5 seconds, I don't remember why I added that. That's past Kevin's problem. If we see any file older than that, we're going to delete it. So it's automatically going to clean up itself. The cleanest folder on the hard drive. We'll go out to the command prompt, and I'm going to bump that up a little bit more for y'all. We're just going to say .NET run. Give it a second. So this is starting a host for me. It is telling me that it is checking the folder C:temp, which I will go to real fast. And as you can see, there is nothing inside of this folder. I'm going to add a file, so we'll add a Word file. And let's see if I can move the stuff around. Now remember, it has to be older than 5 seconds. So not enough time had passed. We're going to wait 15 seconds for it to go. And it should, you ever notice like 15 seconds is an eternity when you're standing in front of a group of people? All right, it deleted the file. Yay, Kevin deleted the file. No, do not applaud for that. No. I would take it any day of the week. I did not deserve it then. All right, that's not deserving. Let's go ahead and shut this down. Let's shut down our file. I'm going to go into my notes. So part of the repository is this awesome README file where I have all the commands for you. We're going to publish a release version of this executable. Let that go for a moment. While that goes, I'm going to open up my services section of Windows. I'm going to scroll down. And I just want to show you, there's nothing in here called tactics, because that's the name of the service. With my build, I'm going to copy another command, and I'm going to open up a command prompt, just because PowerShell doesn't do this particular command very well. And this command is screate, so we're talking to the services layer inside of Windows. We're asking it to create a Windows service for us, and we're telling it the executable for that Windows service. Hit OK, create service, success. If we go back into our services, refresh, scroll up, we see tactic, Windows services. I'm going to start it. All right, running, awesome. We're going to go back into this folder. Now, I don't have any log here because I didn't set it up to log to the event log or anything. We're going to go to C# temp. We're going to create a file. We'll do publisher this time, just so you don't think I'm faking it. And then we have to play the waiting game. I have played with these delays 15 times. And every time I knock, oh, it deleted. Now you can clap. Yeah, I wrote a background service. Well, I didn't really write the background service. I showed you the background service I had written earlier, but trust me, it took 10 minutes. And ChatGPT did like 50% of it. So a background service is running, it's doing the work. It's inside of a hosted service, which .NET just gives to me, and everything is great. Now, jump back into slides. All right, so a couple of pros and cons. I want to talk about pros and cons of all these different ways to go. First pro, you just saw it. This is really easy to build. So if you need something that's running on a server and it's a server you have control over, think about a Windows service, because Windows is automatically going to take care of the lifecycle for you. If the service is running, Windows will make sure it continues running, or you'll get the proper notifications if it needs to shut down for any reason. It is limited to a single server, so if you're running a farm, you have to install it on every single machine in your farm, which is probably not ideal. I always like this is better for an application you're shipping out. So if someone's running your thick client, maybe have a Windows service that goes along with it. Now notice I was doing timed work. Every couple seconds we were doing a check. If I had anything I needed to do on demand, slightly harder to do here. I would have to have some sort of message, service bus or message queue to help the service do the work. So probably not ideal in those cases. And then individual tasks. I didn't have a try-catch around all the work being done. So if it had thrown an exception for any point, so maybe it didn't have access to a file, it was locked by another process, it would throw an exception, crash my background service, but my entire process would still keep running. So that's that's a bad thing. So I'm not protecting myself against myself. I get this question often, what about Linux? Isn't .NET this whole cross-platform awesome piece of code now? Yes, there's systemd support, which I've only played with a little bit, but the same idea. Drop this in, instead of saying use Windows services, you say use systemd, and it does all the work for you. I haven't tested it yet, I'm working on that, but you all should test it for me. Okay, let's take our concept of iHosted service, .NET hosted services, and let's move over to ASP.NET Core, which I'm assuming a lot of you in here might be using. You probably have seen this before. This is the non-startup way, the minimal API way of building applications now, but it's the same idea. We're injecting a service. Same service, cleanup temp folder service, or whatever you call it. You inject it in the same way as you would any other service in your application. And then I have the other stuff that goes along with ASP.NET Core. Yeah, that's all. So I don't need to re-explain how the temp folder cleanup works. I can just jump into the example where I have a slightly altered version of the service. It's still implementing background service and a slightly different delay. The biggest difference is I'm asking the operating system for a temp folder just because of rights. If I were to deploy this to another system, I might not have access to the C drive. I might only have access to certain folders. So if you look at this example, I'm asking specifically for a temp path, which we spit out to the console, so we'll find it here in a moment. In Program CS, it's almost identical, not quite, but the biggest thing that is identical is that we're injecting the hosted service. And we also have a hello world mapping because why not? If I go to command prompt, say .NET run. Now this is going to tell me where my temp folder is, which is in my user folder. Let's go open a, you see there's nothing in there. I'm going to drop in another file. And for some reason, I'm also spinning out the date time. I don't know why I did that. But if we wait a couple seconds, I think this was 15 seconds. it's going to delete that file automatically. Yay. It found the file, delete the file. Yay. Okay, but this time it's inside the context of an ASP.NET Core application. So at the same time, I can open a browser and I get hello world. So I have all the normal things a web app does, but in the background, it's doing resource checks, it's doing whatever scheduled things I need it to do, which is kind of cool. And this is what we've done on a lot of our different apps, where we'll set up a hosted service that listens to a message queue. And if we see something come into the message queue that the web app needs to respond to, we use that as a way to get messages into the ASP.NET Core app to notify others. I told you I have a Signal R course on this. Yeah, I have a whole section where I talk about this specific context, where we get a notification from outside the application, and we send notifications out to everyone who needs to know about it. We use hosted service. All right. Now, Kevin, what if, pros and cons. Biggest pro, again, very easy to build. Literally took the same file with a couple alterations and dropped it into a new application, had the functionality. Because it's running inside your existing ASP.NET Core infrastructure, you can just deploy this. So it doesn't matter if you're running on Azure, your own IaaS, or if you're running on AWS or Rackspace, or you name it. If you're deploying your ASP.NET Core app, you're deploying your services. They start automatically when the app starts up. That's a pro. And there's still the problem where if they crash, you have to deal with that. We also have the problem with scheduling. If I need something to run on a more precise schedule, I have to write that in myself. But here in a moment, we're going to look at what may be a better way of solving that problem. Again, if the process crashes, the entire background task stops, and awesome, it doesn't crash your whole process, but your background services stop working. There are ways to restart a background service afterward. They're just very cryptic and not well documented. Quartz. So I want to talk specifically about the problem of scheduling things, and Quartz is really good about this particular problem. Who's never heard of Quartz before? All right, that's actually the number of hands I was expecting. I thought everyone had heard of Quartz, and I was the last person to the game. I'm not, you are. So Quartz is a high-precision scheduling system. That's a nice way of putting it, where you create jobs, and jobs are just work being done. They're technically the same as background services or I-hosted services. And then you set up triggers for those jobs. So a trigger might be a cron, every 30 seconds, every 3 weeks, every year, or it could be on demand. I need this job to run now. I need this job to run now. Quartz is a little bit more code to get it up and running. It took me more than 5 minutes to create this sample. But here's the general idea. On the left, we are creating a new job, and every job is keyed with a magic string saying this is the job we want to run. And then we point it to a class that implements the job. Then we set up a trigger. In my case, it's going to be a cron saying, well, every 30 seconds, I want to go run this particular task. And there's also stuff with durability. So if you want to make sure it runs every 30 seconds no matter what, you can program it and say, well, what if the entire process crashes and then comes back up? Well, let's pick up where we left off. Is there any cron jobs that we missed? It will automatically pick up from where it left off. Then we set up the server, and it all runs. This is what a job looks like. You have to implement iJob instead of iHosted service or background service. And you have to implement their execute method. Now, with a little bit of work, so that's why I have the packages on the right side, you can set up ASP.NET or .NET dependency injection. So you inject all your dependencies. If you don't do that, you have to do a lot of extra work. So they've created the tools for you. They just take a little bit of implementation. But you set all this up, you get a very similar demo to what we had before. Now here's the code you just saw. We're creating our Quartz instance. We're adding our server. And here is the full job where we create our temp path, and then every couple of seconds, we're checking that path, looking to see if there are any files. If there are any files, we're going to delete them. And this time, I don't have a delay because I'm letting Quartz take care of the scheduling for me. It's automatically going to decide, oh, it's been 30 seconds. Actually, for the demo, it's 15 seconds. But every 15 seconds, we're going to run this job. Let's go back into our code. We'll say .NET run. Quartz is a little chatty in the logs, so we'll give it that. Important things, it is, oh, I have to wait for it to run one time, but it's going to be the same temp directory in a moment. There it goes. All right, so it's looking in a slightly different location. Let's copy that. Oh, no, it's not. All right, we're going to create a file. Rich text again. Oh, so it was too fast for me. I created the file, it deleted it instantly. Do you all really need to see that again? Yes, you do. Excel. I learned the hard way, don't create a new access file because it actually tries to open access, and no one wants to go in access. All right, there it goes again, 15 seconds. All right, maybe it's 5 seconds now. It passed and deleted the file. Except this time it's happening on a more reoccurring schedule because Quartz is controlling the job for me on my behalf. Now, what I really like about Quartz is it's very precise. So I can set up the schedules, I can set up the reoccurrence any way I want to, and Quartz takes care of it for me. I don't like writing those systems. I'm not showing you an example of it, but you can also do one-off or on-demand jobs. Because jobs and triggers are separate entities in Quartz, I can create as many jobs as I want, and I can fire them on demand, or I can fire them on the schedule. It's also possible to set up a separate job server, which I like a lot as your application gets bigger, because you don't want your web app doing all this work. You don't want your WPF or WinForms client doing all this work. You might want to set up a separate job server and just publish the jobs, and your Quartz server picks them up and does it elsewhere. So that way you're not accidentally, I've learned this the hard way, I've accidentally overwhelmed a service that was hosting my web app, and it's like, why is the web app going slow? Well, it's because we're running background services at the same time inside the web app. You don't want that to happen, so we run a separate job server. This is the biggest con, it locks you into Quartz. So if you ever feel like you need to move on to something else afterwards, I've done this multiple times in my career. I start on one thing and then I change my mind. I find a new hammer and my nails change at the same time. I don't like locking into Quartz because it doesn't easily move from application to application or tactic to tactic. At least I hosted service, I can go from console app, Windows service, to ASP.NET Core app. It follows the prescription. If you use Quartz, you have to use iJob. You have to do it their way, which I don't actually think is best. And it's a lot of work if you want to tie into the .NET ecosystem. So if you want to use DI with .NET, you have to do the extra work to make that happen. So, awesome. But it is a tactic that you could use. Next, Hangfire. I put Hangfire in because I have a special place in my heart for Hangfire. Who uses Hangfire? Who loves Hangfire? Yeah, Hangfire is really cool until. I'm going to get to the until in a moment. Hangfire basically takes the great parts of everything else that we've talked about and gives you a UI for it, which who doesn't like a good UI? Like, there are so many people out there who just hate command line terminal stuff, and they see a UI and they get giddy. This one has even got charts and graphs that are just useless. But Hangfire is really cool because you don't have to tie into their way of thinking. Like with Quartz, I had to implement iJob. With iHosted Service, I had to implement iHosted Service or background service. With Hangfire, I just write my own class, which I might already have sitting around doing its thing. I could take my existing class with my method names, my list of parameters, my complex objects, and I could just go in, and sorry for the code, I could just say, well, I'm going to add a job, and you're going to use my class. In Hangfire, you're going to execute my method, and it also supports the reoccurring task, the crons, so which is the example here, recurring job every 30 seconds. We're going to do something. But I can also schedule future work to be done. So don't do it right now, but do it in 30 seconds from now. I can schedule a job for later to be done. And I'm going to show you another example here in the code. But the best part of all is you get the fancy UI if you set up the mapping. And it ties into all the ASP.NET stuff, so you don't even have to worry about your own authentication. You just tell Hangfire, use my ASP.NET Core authentication that I already have. And it's like, okay, cool. It does all the work for you. So let's jump into the demo. Let's turn that off. All right, so Hangfire looks, this is actually the thing I hate about the minimal API, like file scoped, everything. It looks like a lot of code, but it's really not. We're just building on what we already have. The first thing I'm doing is I'm adding Hangfire. A thing you have to do with Hangfire is you have to have a backing service. By default, they use SQL Server. SQL Server is the worst way to host these jobs. Don't ask me how I know that. If we have time, I will tell you the story of how I DDoSed myself. Now you're like, hurry up, Kevin, I want to hear that story. All right, so I have Hangfire. It's going to run a job every 30 seconds. Temp, clean up the temp folder. We set up some Hangfire stuff. I also have two methods. Because it's an ASP.NET Core app, right? I can write methods that do work. First one is generate now. So I figured, if I have a service that's cleaning up the files, why can't I create a service that creates the files for me? And creates a lot of them. So I have two of them. The first one generates the files now, and then the second one generates them later, which we'll get into that. I'm going to run this code. Oh, this show you. So slightly different, same concepts implemented in a slightly different way. This is my own class, no implementations. We're going to get the temp folder. We're going to see if there are any files in there. If there are, we're going to delete them. Yay. Go back out to the command line. We'll say .NET run. All right. Because I gave it a SQL Server connection string, it's automatically connecting to SQL Server. It's creating tables in its own schema for managing Hangfire, and it's going to give me my instance. Now it's sitting here and it's running. I'm going to open up a browser. Now, so I have Hello World, and this should be a different port. Yep, different port. So you know it's different. I'm going to go to /Hangfire and zoom out. There we go. You get this fancy UI if you're using Hangfire and you turn it on. You don't have to use the UI. The UI does give you a couple of cool things. It tells you current jobs you have queued, either in queued to happen next, things that are scheduled to happen later, things currently in process or currently processing. It shows you your successes, your failures. It's like your mother, right? It's like, you're so close, but yet so far you failed. You could delete jobs if you need to. I've actually never put anything to a waiting, so we'll just skip that. If a job fails, it's going to give you the opportunity to retry. It's like, well, you failed this time, but we're going to give you 10 more chances. And if you fail that 10th time, we're just going to pretend you're no good, and we're going to throw you away. So you can watch the retries here. We can track our reoccurring jobs. So here's the reoccurring job I set up. It's telling me the cron instance, like how often is this going to run, and what file, what namespace method is it going to run, and how often is it going to run. So this is running every couple seconds. If I go into the jobs folder, we can see my successes are many. It's just because it's running, it's waiting for me to do some work. And, oh, actually, I'm sorry. Some of these are from when I was testing the demo earlier. So disregard anything 5 hours ago. let's go ahead and generate some jobs. So I'm going to go into my temp folder. So this one's in temp job for some reason. Let's put our files side by side. And we'll say generate now. All right, it generated a whole bunch of files. Now, and they're gone. Let's go see what Hangfire did. Well, Hangfire, this is our generate call. And it's telling me I activated an instance of, so here's how you read it, read the logs. It's also what I love about Hangfire. We activated an instance of cleanup temp job, our temp folder job, and we executed the generate method on it. And it shows you the logs of all that working. When was the job created? When was it added to the queue to be done? When did it start processing? How long did it process for? When did it succeed or when did it fail? If it failed, when was it retried? If it retried, did it succeed or fail? And it keeps doing all that until it fails for the 10th time or it succeeds. If you want to, maybe I want to try this again. I'm debugging an issue, and I know it occurs in this particular instance. I can say requeue. It gets added back to the list. Files get added back. I didn't actually go run the command in the browser. I just reran the job. And we'll wait a moment, and it'll clean up again. I wish there was a way I could time that where I would say again, and it would, never mind. All right, now this is really smart, and I'm going to schedule another one and say schedule, what do I call it, later. And this shows you a scheduled job that's going to occur in a few seconds. And how well does it show? Yeah, you can see scheduled is blue for 1. And if we wait a couple seconds, it'll turn 0, and it'll execute the job. In a few seconds. All right. So it's going to run. Oh, so I had a race condition on myself. I generated and cleaned it up within like a millisecond of each other. Okay, so it did the job. It generated, then it cleaned up. Here's the one key thing I want to show you. Let's go into this, and I'm going to add a property that doesn't do anything, but I just want to show it to you. Name. And let's see, where's my generate? So this won't compile now, but we're going to generate a name with a GUID, and we'll do toString. I'm going to pass that name into, does it generate? Oh, no, let me put it in generate. Generate's better. And then we'll add a log because you should log everywhere. Hey, oh, I have Copilot on. So, who's using Copilot? See, every hand should be up right now. It is really cool when it's really cool. It's hilarious when it's not. All right, so I'm going to log out the name. I'm going to add, see, Copilot doesn't know what I want. There we go. All right, we're going to spit that GUID out. And what I'm really trying to show you here is I want to pass parameters. So I'm going to pass a GUID into both those cases. We'll go out to our terminal. We'll restart the service. And we are going to generate now again. I'm going to generate. You can see here, I have a slightly different log, and it's telling me what parameters are being passed. Now, there's a couple cool things here. I'm sending a string, but I could very well send an integer, I could send a decimal, I could send a complex object. If I pass in my own complex object, Hangfire automatically serializes that to JSON, stores it, and makes sure that all the data I intend to send gets sent along. I'm not going to go through the demo right now. Just trust me on that. You can send very complex objects, and Hangfire takes care of all of it for you. The other thing you can do, so go into the pros and cons for Hangfire. Again, you have very precise scheduling and timing, making sure you have things that run exactly when you need them to run, give or take a couple milliseconds. If I need to do jobs on demand, Hangfire makes it extremely easy because I'm just telling Hangfire, hey, go do this work for me, please. Everything I run is strongly typed. So I'm using my own code, my own methods, their parameters. I don't have to abide by the man's rule of implement this and have the methods I expect you to have. I can use all my own stuff, and there's no magic strings. I think magic strings are the worst, and I have absolutely no magic strings here. Having UI is super useful because I don't know how many times someone has come to me saying, Kevin, the job for whatever failed. And I go into Hangfire, go find the failed job, and it's like, oh, that's right. We changed the configuration object, and we didn't make the change throughout the board. So I can just look at the error, and I can see the error over and over and over again. And then I can go make the fix, and everything starts working. You do have to use SQL Server as your default backend store. I don't have the time to explain how I DDoS myself, so feel free to grab me outside afterwards. If you want to use a better data store, like Redis, my Redis guy's not in here, it's paywalled, so you have to pay for Hangfire Pro in order to get the Redis stuff. But it's kind of worth it. But there are also ways you can hack the SQL Server instance to not DDoS yourself. You can run a separate job server. I do that. It's a pain in the butt, and I don't recommend it for anyone because there's the problem with running a separate job service is because we have strongly typed jobs. And when you make a code change in one place, you have to deploy it in two places, and it causes a bit of an issue. Now, we run Hangfire in production on several projects I'm involved in. And the nice thing about it is it does everything we need to do. But we are starting to hit these walls where Hangfire is not enough for us, specifically around deployment, having the separate job server. We are moving on to another service that does the same thing and I think is the best way possible, and that's Azure Functions. I used to be that guy that sat in my chair and went, serverless is just other people's servers. I have converted. I drank the Kool-Aid. It is good. It is. It's like a grapey fruit punch flavor. It is really good. I love serverless. I love Azure Functions. I like Lambda. I haven't done a lot of Lambda, but it's there. It's solving the same problem, just differently. I love this stuff. Here's an example of an Azure function. Azure function works on the same concept as everything else that we've talked about. We have triggers, and we have work being done. So a trigger here in this case is a timer trigger. So I'm using my own class. I'm just decorating the method in a certain way. I'm telling Azure Function, here's a method that I want you to know as timer get RSS feed. I want you to run every 30 seconds, and we do the work inside of the dots. Now, this is great for timers. So I could have as many timers throughout the entire app as I want, but you have a lot of different triggers that you can use. You're not doing just timer triggers now or on-demands like webhook triggers. You have a cookbook. You can even write your own. So in our application, we use a lot of blob storage triggers because we're on Azure. We use, what else we use? Queue storage all the time because queues are the most efficient way for us to really send data around our different workflows. We're too cheap for Service Bus, so we don't use Service Bus. That's a different story. Timers all over the place, but there's a multitude of different triggers that you can use, but the whole idea is that we want to move our code, our background services, out of our systems, and we want to put them in a more, I love the term cloud scale now, I didn't used to love the term cloud scale. But cloud scale is effectively what we want. Now, I'm not going to go through this whole demo. You know what? Yes, I do. I have enough time. So here's the demo. It's setting up a timer trigger to run every 30 seconds to go off to my website, get the RSS feed, and it drops it into a blob storage. That's all it does. So a couple of little things with this example is, first, it's C#. You could also write these in JavaScript. It's a lot more hassle. And there's 2 or 3 other languages functions are supported on as well. But we're going to take the code and we're going to output it to a blob store, which I just gave it the location in my attribute. And this is going to run every 30 seconds. Now, to show you, I haven't done this already. Do a zoom. There's no folder in here. It's going to be called output. So zoom out. Let's start our Azure function. All right, so it's running, and in about 30 seconds, it's going to show you the job running to go off to my website, grab the RSS feed, bring it back, drop it into a folder. So we use timers all over the place for different sort of cleanup jobs. We use them for report jobs. I have one that runs every day at 9 o'clock Pacific time in the US, and goes off to a database, gets some data, brings it back, creates a report. All right, so we just ran. So now if I go back in the blob storage, zoom in, refresh, nope. All right, we have our output file, and there's my RSS feed, which I'm not going to show you. But it's there, and it's doing the work. Now, I use Azure Functions for webhooks. So all the Stripe stuff I talked about a little bit earlier, these are services that we kind of rely on. We expect them to do. We need to know when these notifications come in. We put those in Azure Functions because the Azure Functions are always running. If our services are being overwhelmed at the time, the functions just create more instances. They scale up naturally. So we very rarely ever miss a message because of our fault. Now I'm trying to wrap this up. Big pro of Azure Functions, or serverless in general. I use the term Azure Function just because I love Azure Functions. Precise scheduling and timing. And we're talking up to the millisecond it runs when you expect it to. It'll run once, even if you have 20 servers all running in Azure Functions. If it fails for any reason, it's automatically going to try again until you tell it, or up to 5 times. We have a lot of options for triggers, not just hooks or on demand or timers. We can do blob storage, queue storage. You can write your own. Cloud scale. I love cloud scale. There is nothing more satisfying than dumping a queue with 500,000 entities and watching Azure just go nuts on it. Where before we had our own little console cron job that would just for each over everything that we had in a queue. And that worked. It was slow. But when you divide that across 20 servers, it knocks it out in no time at all. And it costs 3 cents at the end of the month when we're all done. I love cloud scale, and I'm a convert to all the serverless stuff. Our tasks are independently resilient, so if one thing crashes, it doesn't affect anything else. If I don't even have to really try catch around any of my services. If they fail, they might automatically retry themselves, like timers, or I can get a proper notification that they did fail. Big con, well, for Azure Functions, you have to be on Azure to use Azure Functions. But if you're on AWS, you have Lambda. And there are other providers out there that provide serverless aspects. All right, so big conclusion. I hope I taught you something. That's kind of what it comes down to. I hope I put some tools into your toolbox. And I hope that if you aren't already doing some work in the background, or at least saving calls for later, I hope you take some of these concepts back to your jobs and maybe force some change. Everything should be in the background, in my opinion, except very critical UI items that need to be done. But with all that said, I am happy to stick around to answer any questions you have. If not, I will see you all at the pub. Have a good night.